In this video series, we're going to be taking a look at formulas as well as some other video series. We're going to be taking a look at trigonometric formulas. And we're going to start off with the sum and difference formulas. And so the objectives for this lesson, we're going to start by proving one of the sum and difference formulas. We're going to do it for the cosine difference between two angles. And then we're going to use sum and difference formulas for cosines, sines, and tangents when appropriate. Okay, so we're going to see a lot of different applications as to where we can use these. So these are formulas, okay, that we are going to use throughout this section. All right, so basically X and Y are going to be some angles, and all we do is we just substitute those back in to the given formulas, okay, and these both are the same, okay. Now, what I'm going to start to do in this video is I'm going to verify the difference between the cosine. Okay, so cosine of x minus y equals cos x minus, or cos x cos y plus sine x sine y. And these proofs are a little bit rigorous. You won't be expected to do these on an examination, but for those of you that are going up higher in mathematics, it's probably beneficial for you to know where they came from. All right, so first of all, let's have these two diagrams on the unit circle. Okay, so and what we have is we have two distances. All right, so I have a distance, and I'm going to call this like distance 1, and I'm going to call this distance 2. And it's just known to us that these two distances are equal to one another. Okay, and so the point 1, 0 to this point right here, cos alpha minus beta, sine alpha minus beta, that distance should be equal to the distance between this point, cos beta, sine beta, to cos alpha, sine alpha, okay? And so what we're going to do is we are going to find the distances algebraically, and that'll help us to verify this formula, all right? So there's a lot of algebra that's going to be involved in this, so just hang tight with these. So let's find distance 1. And so distance 1 is going to be equal to, and just to remind you of the distance formula, um, let's start with that just in case we forgot distance formula. That's going to be x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, right? And so I'm going to do this down here. So for our first distance, which I'm going to call distance 1, that's going to be equal to the square root of cos beta minus cos alpha, okay, or vice versa. So let's use cos alpha minus cos beta. Doesn't matter that much. So cos alpha minus cos beta squared plus sine alpha minus sine beta. So sine alpha minus sine beta quantity squared. All right, now what I'm also going to do is I'm going to FOIL this out. Okay, and so distance 1 is going to now be equal to, hang tight because this is going to be a little bit messy. All right, so remember, when we FOIL something out, we just write it next to each other. So this is really going to be cos alpha, cos beta minus cos beta. All right, so let me write this out just one time, just so we can see it. So this will be cos alpha minus cos beta times cos alpha minus cos beta. All right, and if we FOIL that out, okay, that's going to turn into cos square alpha minus 2 cos alpha cos beta, and then plus cos square of beta. All right, so that's just foiling this one out. Now let's FOIL this one out as well. And so that's going to give us a plus sine square alpha. All right, so just imagine that this is just going on to another line, minus 2 sine alpha sine beta, right? And then plus sine square beta. All right. Now, although that's ugly, I want you to notice that we have a cos square alpha and a sine square alpha, and we're adding those together. And remember, Pythagorean identity suggests that that's 1. And also notice right here that we have a cos square beta plus sine square beta, so that's also 1. And if we add these together, 1 plus 1 is going to give us 2. All right, so this expression, d1, is going to be equal to the square root of 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. All right. Now, last thing we're going to do is we're going to square this. Okay, so if I was to square this animal, then that would just remove the square root from that. So let's hold on to this, okay? Because that's distance 1 squared. Okay, so I'm going to hold on to that. And now what I'm going to do, and this is a lot easier, I'm going to find distance 2 squared. Okay, and so for distance 2, that's going to be equal to the square root of this. Let's just use this as the first point. Doesn't really matter which one. So let's say cos of alpha minus beta minus 1 quantity squared. We're going to have cos of alpha minus beta minus 1 squared plus sine of alpha minus beta minus 0 squared. Okay, so this is going to be sine of alpha minus beta minus 0 quantity squared. Right? Now, once again, we're going to FOIL this out. Okay, and this one's easy because when we have the plus 0 in there, it just goes away. So distance 2 is going to be equal to the square root. All right, so this is going to be a little bit ugly, but that's okay. So we're going to have cos squared of alpha minus beta minus 2 cos of alpha minus beta plus 1. And now we just have plus sine square of alpha minus beta. Now, just like before, notice that we have a cos square and a sine square. And even though the interior angles, it doesn't matter as long as they're the same. So if we had cos square of elephant plus sine square of elephant, that's always going to be 1. And then we have this 1 plus 1, which is going to be 2. So d sub 2 is going to be equal to 2 minus 2 cos alpha minus beta, right? And then finally, just like we did before, we can square both sides, and we're left with this expression. All right, now, what I'm going to do is I'm going to set these two expressions equal to one another, okay? And this is the last thing we have to do to prove this. So we're going to have 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta is going to be equal to 2 minus 2, and I'm going to squeeze this in here, cos alpha minus beta. Right? Now, one last thing I want you to notice is there's a 2 on both sides. Those will cancel out. And if I divide everything by -2, okay, then what's going to happen is all the -2's are going to become 1's, and I'm left with cos alpha cos beta plus sine alpha sine beta is equal to cos of alpha minus beta. All right, and that is our formula for the sum and difference, or for the difference formula in this case, excuse me, for the cosine of alpha minus beta. So cos alpha cos. So notice we have cos cos plus sine sine equals cos of alpha minus beta. And so if we go up here, we have cos cos plus sine sine is equal to cos x minus y. So we can just replace x with alpha and y with beta. Okay, so that's how we have to prove a lot of these. Okay, and the proofs are fairly rigorous. Okay, again, I'm not going to ask folks to be able to prove these on examinations. Okay, but just for those of you that want to know where these formulas come from, somebody figured out that these are equal distances, and then they just went through algebraically and proved these. All right. Now, the stuff that I am going to put on the examinations is going to follow everything in the next videos. Okay, so make sure that we can do these applications that we're going to see in the next videos in this section.